Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter electric charges and fields. So any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. In and in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter in the comment section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it has been told that which of the statements is false in the case of polar molecules. Centers of positive and negative charges are separated in the absence of external electric field. Centers of positive and negative charges are separated in the presence of external electric field, do not possess permanent dipole moments. Ionic molecule HCl is an example of polar molecule. So it is told that they do not possess permanent dipole moments. It is wrong. So option C is the correct option. Since why it is the wrong statement. It is a false statement. So then here it has been told a tiny spherical oil drop carrying a net charge Q. A small tiny spherical oil drop is spherical and it carries a net charge Q. It is balanced in air with a vertical uniform electric field strength of 81 pi by 7 to 10 power 5 volt per meter. When the field is switched off, the drop is observed to fall with a terminal velocity Vt, terminal velocity, let's call it V1, fall with terminal velocity 2 into 10 power minus 3 meter per second. And here G is equal to 9.8 meter per second square. And viscosity of air, that is eta, coefficient of viscosity, it is 1.8 into 10 power minus 5 Newton second per meter square. And the density of the oil drop, that is equal to 900 kg per meter cube. Then the magnitude of Q has been asked, means how much is the charge. So here, as we know that it is falling through air, viscosity of air is there. So therefore here you can say that the forces which are acting on the charge Q are, one is QE, that is upwards, and one is mg, that is downwards, and the viscous force, that is 6 pi eta rv, and the upthrust, that is the buoyancy force, that is v rho g. V is the volume, V into sigma into g, where sigma is the density of air. So here we know that the density of the oil drop is obviously much more than the density of the air. So it means the density of air we can ignore it. Means the buoyancy force can be ignored. Therefore, we can tell the upward force, that is QE plus 6 pi eta RV, that will be equal to mg. When when the terminal velocity is reached, then the net upward force should be equal to the net downward force. So from here, V we have to find. So that is Q will be m. M is 4 by 3 pi r cube. Viscosity. Okay. E into the density of oil into G of oil to G minus 6 pi eta RV divided by E. Now, what is not told is the radius of the oil drop. When the field, okay, so it is told when the field is switched off, it is observed to fall with a terminal velocity this. That means when the electric field is switched off, then this will become 0. So then 6 pi eta R V will be equal to mg. So then from here we can say that the terminal velocity has been told. From here, okay. So therefore 6 pi eta RV, that will be equal to 4 by 3 pi R cube into density of oil to G. So therefore we can find out R from here. So from here pi and pi will cancel out. 2 to the 4, 2, 3 is 6. So this will come 9 by 2 eta V, that is equal to 9 by eta V, that is equal to 2 density of oil into G. 2 density of oil into G into R square. No. Density of oil into G into R square. So from here we can find out the radius of the oil drop. And when it is balanced in still air, then we can say that QV should be equal to mg. QV equal to mg. So from here we can find Q. Q will be equal to mg by E. So then from here R square is equal to 9 eta V by 2 density of oil into G. So this will be equal to 9 into eta. Eta is 1.8 into 10 power minus 5 to V, the terminal velocity, that is 2 into 10 power minus 3 divided by 2 into density, that is 900. 9 into 10 power 3 into G. G is equal to 9.8. Now, if we solve it, then we'll get 2 will cancel, 9 will cancel. This will come 1.8 divided by 9.8 into 10 power minus 5 minus 6. It is minus 11. So this will be 2 9s 18, 2 4s 8, 9s 18. So 9 by 49, which is approximately, write 90 divided, we can write 9 by 49 or minus a 5. Density is 9 into 10 power 2. 10 power 2. So this will be minus 10. Okay. So it means R, the radius R is square root of this. So this is 3 by 7 into 10 power minus 5. So therefore Q will be equal to mg. Therefore we can say Q will be equal to m. M is 4 by 3 pi R cube into rho into G. Or here we have also found that we have also showed that mg equal to 6 pi eta rv. So we can also say q will be equal to 6 pi eta rv divided by e. So this will be 6 into pi into eta is 1.8 into 10 power minus 5 into r. R is 3 by 7 into 10 power minus 5 into v, terminal velocity, that is 2 into 10 power minus 3, 10 power minus 3 divided by e. E is equal to 81 pi by 7 into 10 power 5. 81 pi by 7 into 10 power 5. So by 7, so this 7 will cancel, pi and pi will also cancel. Then here we can write this will be 6 3 is 18. 18 into 1.8 into 2, that is 3.6 into 10 power minus 10 minus 15 minus 3, so that is minus 18. Six pi eta r e divided by e. Pi has cancelled, 18 minus 18. So this we can also write it as magnitude of q. Okay, here I think g should be okay. Despite r v and mg should be same. So we can also write this as q equal to mg by e. So this will be q will be equal to m, which is 4 by 3 pi r cube into rho into g by e. This will be 4 by 3 pi into r cube. So this is a 9, 3 9 is 27, 27 by 7 cube. So 49 into 7, 10 power minus 15 into rho. Rho is density of oil, that is 9 into 10 power 2. 9 into 10 power 2 into g, 9.8 divided by e. E is 81 by 7 pi into 10 power 5. So this will come by 7 will cancel. So this will cancel out. 3 9s are 27. Then 9 9s are 81. So then this is coming 4 into 9.8 divided by 49 to 10 power minus 13 minus 18. So this will be equal to 4 into 98 divided by 49. 49 is 49 2s are 98 into 10 power minus 19. So 8 into 10 power minus 19 coulomb. So it means that it is option D. Option D is the correct answer. Then here it has been told that a charged particle of mass m A charged particle of mass m and charge q is released from rest in a uniform electric field. It is released from rest in a uniform electric field, neglecting the effect of gravity. The kinetic energy of the charged particle after t seconds is. So here we have to apply the work energy theorem, that the work done by the electric field is equal to the gain in kinetic energy of the particle. So it is released from rest, so initial kinetic energy will be zero only. So final kinetic energy minus initial kinetic energy equal to the work done by electric field, which is E into, means, which is QE, force into distance, force into the length which it will travel. Let's say that is x. So we know that x is equal to uh, ut plus half at t square. It starts from rest, so it will be half into acceleration into t square in time t. Now the acceleration will be qv by m. Therefore, x will be equal to qe by 2m into t square. So therefore, the final kinetic energy after t second, initial kinetic energy is zero only. So that will be qe into qet square by 2m. So that is q square. So I can say it will be e square q square t square by 2m. So option C is the correct answer. Then it is told that 4 charges plus q plus 2q plus q and minus 2q. These are placed at the corners of a square ABCD respectively. Corners of a square ABCD respectively. So at A charge plus q is kept, at B charge plus 2q is kept, and at point C charge plus q is kept. And at point D charge minus 2q is kept. Minus 2q is kept. Force on a unit positive charge kept at the center O is. Force on a unit positive charge. So unit positive charge means plus 1 coulomb charge has been kept at the center. The force on it will be. So now these two forces will get cancelled. This force, this is the same repulsion as from C. These two forces are equal and opposite, so they will cancel out. And these two forces will be added up. This is why here so here there will be a repulsion and here there will be attraction. So these two forces will be added up. So it means the net force will be along the diagonal BD. Net force will be along the diagonal BD. So option D is the correct answer. Then here it is told that an electric dipole with dipole moment 4 into 10 power minus 9 . So it will be 4 into 10 power minus 9 coulomb meter. It is aligned at 30 degrees with the direction of a uniform electric field. With the direction of a uniform electric field. An electric dipole P vector, it is aligned at a direction of 30 degree with the uniform electric field. And the dipole moment is 4 into 10 power minus 9 coulomb meter. And the electric field is of magnitude 5 into 10 power 4 Newton per coulomb. Then the magnitude of the torque acting on the dipoles. So magnitude of the torque acting on the dipole is magnitude of P cross E. So it will be equal to PE sine theta, where theta is the angle in between the dipole moment vector and the electric field. So P will be 4 into 10 power minus 9 into the electric field is 5 into 10 power 4 into sine theta, which is sine 30 degrees half. Sine 30 degrees half. So this will be into half. Into half. Okay. So then, therefore, we can say that this will be, so 2 2s are 4, 2 5 is a 10, 10 power 4. So here we have to find the magnitude of the torque which is acting on the dipole. So that will be 2 into 5. So this is 10, 10 into 10 power minus 9 plus 4. This is 10 power minus 4 Newton meter. So option D is the correct answer. Yep. So hope all of you have understood the solutions of all these questions on the previous year KCET exam. Still any doubts if you have, then please write that in the comments. And also please install our Sapience Education application where we shall upload some important homework questions based on the previous year KCET exam, which shall be helpful for your exam. So thank you everyone. Bye.